All right, people, I don't know how this is going to sound at home, having some microphone stuff, but here we go. Everybody here, y'all ready? All right, so real quickly, we're going to review what we talked about yesterday. And this video is going to be short, so KHD space DCM. Now, in reality, you don't really use capitals on the left. Okay? Now, I like to use the capital, to sort of emphasize that these are the big numbers and these are the small numbers, right? Does that make sense to everybody? So if we look on here, KHD space DCM, this space, these are going to be your regular units, meters, liters, and grams, okay? Depending on length, liquid volume, or mass. All right. Kilo, hecto, deca, space, deci, centimilla. If we're going to make abbreviations, let's say we're talking about meters, okay? If we're measuring things, this would be km, this would be hm, this would be dam, this would just be m, this would be dm, this would be cm, this would be mm. Those are the way the abbreviations work. DA means it's deca with a K instead of deci, right? You can also, I'm pretty sure, put a K here and write DKM to make it clear. And if you did that and someone told you it was wrong, you would still say, well, you knew I meant deca and not deci, right? So really quickly, here's what we're going to do. Let's try a couple of these. Ready? Let's say you had, 31 meters. 1. So the 1 needs to be under meters. So 31 meters. How many kilometers would that be? How many kilometers would that be? 0.031, right? And then if you had 31 meters, that will be 3.1 decameters. Or if you had 31 meters, that'd be 31,000 millimeters, right? Everybody with me? All right, cool. So that's how we use this little chart. Now, let's say we had 709 meters, okay? Ready? 709 meters, okay? And let's say we wanted to transfer that to millimeters. So it'd be 709,000 millimeters. So I could say right here, I could say 709 meters, this is like what was on your homework, equals blank millimeters. And then you could write 709, comma, 1, 2, 3. Now that's a lot of numbers to write down. So usually we don't write numbers like that in what we call standard notation. We usually write them in what? Do you know? Scientific notation is exactly right. So we're going to do a short lesson right now on what scientific notation is, okay? First of all, the purpose in scientific notation, what we do for scientific notation is we're trying to be clear without taking up a whole page of numbers, right? For example, there are this many atoms of hydrogen in 1 gram of hydrogen. 6.02 times 10 to the 23rd. Now, if I wrote that as a number, it would literally go all the way across the board, right? So I use scientific notation. One thing you should know about scientific notation is that we always put one number in the ones place, okay? And we slap a decimal. We add the other numbers that are important. And then we put times 10 to the exponent, okay? You've seen this before. This isn't new. So, the only catch you can have is when you're dealing with zeros. And people at home and even people in here, I'm gonna go pretty quickly. So if you want to rewind the video, rewind it. All right. Zeros. Let's take a look at this number right here. 100, okay. 100.1, 0.001, and 1.00. Now all these numbers are different, okay? Now if I'm going to write the number 100 in scientific notation, I can write 1 times 10 to the second. If I'm going to write the number 100.1 in scientific notation, I have to put 1.001 times 10 to the second. So in other words, these zeros are important. These zeros are not important because I can write the number like that. I don't need to put them here. But since these zeros are trapped in between these two other numbers, then you have to use them. Does that make sense? Let's look at this right here. Are these zeros important? What do you think? Yeah, they're not. Check it out. Watch me write this number. 1 times 10 to the negative third. That's it. I didn't need to use those zeros at all. Everybody with me? All right. What about this number? 1.00. 1.00 is different, okay? Is different than 1. If I wanted to stupidly, okay, write 1 in scientific notation, I'd write 1 times 10 to the 0. And that'd be a pain in your butt, but that's technically the answer, okay? But 1.00 means something different. Here's what it means. Let's say someone came in, they said, Mr. Perkins, how big are the desks in your room, okay? And I went, they're like a meter wide. Then that's this number. If they said, Mr. Perkins, how wide are the desks in your room? We need to know exactly because we're going to bring a truck and we're going to see exactly how many we can fit in there. And it's going to cost us a lot of money. So then I go, and I'm like, oh, okay. And I take my meter stick and I lay it down on this imaginary desk. And the desk is exactly that long, right? And I measure it, and it's a perfect meter stick. Not even with an extra millimeter of distance, right? It's not 101 centimeters. It's not even 100.1 centimeters, right? It's exactly 1 meter, no centimeters, no millimeters. Then I would write 1.00 because that shows that I was super picky and that I measured it exactly. Does that make sense? So now these zeros, they're important. They're showing that you were really trying and that number is exact. So if you saw 1.00, you'd have to write 1.00 times 10 to the 0. That's a different number. That's way more specific. Does that make sense? So scientific notation. Let's just do a couple of them just for fun, because I know how much fun this is. That is sarcasm. All right, ready? 236 in scientific notation. 2.36 times 10 to the second, right? Where does this to the second come from? Well, I took this decimal right here. It used to be right here. And I moved it, boop, boop, 2 places. So 2.36 times 10 to the second. With me? Now, at home, if you're trying this on the computer or whatever, get yourself a calculator, put it up on the screen. If you're not sure if you're right, check it. Right? Simple. All right? Let's try another one. How about 0.0159? All right? We're going to write that in scientific notation. So we have to write 1.59. Remember, we have to have this one digit there. 1 times 10 to the. Now, the decimal was right here, and we moved it 2 places that way. Times 10 to the negative second. Okay? Everybody feeling that? At home, if you're lost, rewind the video, play it again. Another hint, if you're at home, you can play my voice in 1.5 speed or 1.25 speed. It makes me seem super irritated, which is pretty funny when you're watching it on YouTube. It makes me seem like a jerk. But it's funny. But just rewind it and watch it again, because that's pretty much it for scientific notation. And we'll give you a really short assignment. People at home, we're going to do a little bit more in the classroom, but people at home, you're going to have a pretty short assignment. Then we're done, because this is just review, right? Scientific notation. And I think that's it. I don't think I have anything else to add. That's our little review from yesterday, and reminding you how to do scientific notation. All right, cool.